Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're going to talk about lithium iron phosphate batteries. So let's dive right into it. Well, first we have to understand what the hell we are talking about. We are talking about one type of lithium ion cell. It is still lithium ion. Only difference is in the positive electrode, because batteries have two electrodes. We had made some changes. Instead of using cobalt or nickel, something like that, we are using iron. Now the reason for that is it will become more apparent as I explain more about it. But you can see, like, most time when you talk about EV battery, basically Tesla batteries or Porsche batteries and things of that nature, generally they are using lithium ion system, and your mobile phone is using lithium polymer system. So polymer has a bit of different structure, but more or less it's the same. However, this time we are changing the electrode itself. So electrode is going from cobalt to iron, and that is why it's classified as lithium ferro phosphorus battery. Basically, Le lithium, Fe iron, Po O is oxygen, and P is phosphorus. So this is why lithium iron phosphate batteries. So why the heck we wanna go from lithium ion to basically lithium iron? One simple reason: lithium is very reactive. It is inherently very reactive. So if you have just lithium, raw, unprocessed, unoxygenated lithium, it will catch on fire oxygen. You don't even need to ignite it. It is inherently very reactive. That's why we use it in battery. So lithium can burn like crazy. Like, to give you a context of that, if lithium ion battery pack ever catches on fire, it's damn near impossible to put it out. And like, this is what happens on an EV car if it catches on fire, especially if it has lithium ion system. It can literally melt through the chassis. It is very energetic. It's not something that you can troll around. On top of that, this is still a fire, but it can happen so rapidly, it can reach almost into the territory of explosion. So again, hopefully this was catching on fire rather than exploding, but it does happen many times. It has happened on laptops, mobile phones, things of that nature. It can explode. Basically, it can decompose. It can decompose so rapidly it becomes almost like an explosion. So it is something very dangerous, and the bigger the pack you're using, the more dangerous it becomes. So it requires special care. Now, even if people don't like lead acid batteries for, oh, it has lead, or like, it's old technology or something, like lead is very time tested. It's something that we can forget and abuse to nth degree. If we ever started treating our lead basically lithium battery packs as we are treating our lead acid, it's going to detonate on us. So we needed a change. So we created this alternative. Lithium ion has its uses, but somebody created this whole system of lithium iron, and people started using, because it's safer and stable. Now, what does that translate to? Like, what does you get out of it if you are paying for this? Well, it has a longer lifespan because it's less reactive. Inherently, on a chemistry level, it is less destructive to its own electrode, so it's not going to destroy itself. So if you take a normal lithium system, the expected, like, real life expected lifespan of charge cycles are very low. You are talking about like 600 to 1000. This puppy can go up to 3 to 5000. So that's a very significant upgrade. On top of that, stable chemistry makes it stable. What does that mean? That simply means it can operate on a much larger temperature range. So if outside temperature, let's say you have it in a garage, and in winter it went low, and I mean like really low, it went as low as minus 20 degrees Celsius. It's like, yeah, I don't care. Normal battery will start to panic. Simply, it might even start losing charge or might get damaged if you try to charge it. This puppy is like, I got this, bro, no problem. Now in summer, let's say start to heat up, it's like, I got this. Now, normal cells are generally like best kept at under 30 degrees Celsius. This puppy can handle up to 50 degrees Celsius. Some specifically built with much wider kind of temperature range, and they can have literally 100 degrees Celsius of operational temperature range, depending on how you choose it. So you get the idea. Like, it is stable. It's less reactive, absolutely, but it is stable, and that translates to 3 times longer lifespan. So basically, let's say you build a power wall using this technology rather than lithium ion. Yes, it will be bigger because, again, less reactive. It does not have the oomph. So you will have that side effect. However, you don't need cooling with that, because you can see it's generally much more temperature resistant. And if something bad happens, nothing will happen. Like, it will not catch on fire. It will not set your building on fire, because you have to know lithium fires are dangerous as hell. So that is why we are starting to use lithium iron phosphate in many places. Especially if you see something yellow block like this, 99% of the time it's lithium iron phosphate. Now, what about the uses of this? Well, now this is one very critical aspect you have to understand. When we say 12-volt lead acid battery, it's just a vague term, because if you measure, if you have a multimeter, you measure any lead acid battery, it will rarely be 12 volt. It will if it's a good battery, if it's charged, it could be as high as 14 voltage, and if it's very discharged, it will be 10 volt. So when we say 12 volt, we mean a range of voltage. Now what does that mean for you and I? Basically every electronic that you buy, let's say be it UPS, be it inverter, be it emergency backup systems, when they say 12 volt battery, they have that temperature range pre-built into it, because lead acid has been being used for 150 years. So every Tom, Dick and Harry knows how to handle that. Like every car alternator to every charge controller knows how to handle lead acid very well. This is how I'm going to charge it, and this is how I'm going to float charge it. Everything is done, and that voltage range can be used. Now you might be like, okay, lead cells, basically lead acid battery cells, are not very high voltage, so you need 6 of them for 12 volt. What if I use 4 cells for of lithium ion to get quote unquote 12 volt? Now does it work? Absolutely. Here's the problem: you cannot utilize it, simply because your voltage range would be so up that, think of it, it would be like you have 100 liter of water tank, and you can only fill it up to 45 liters and only discharge 30 liters. You will not be able to use the full capacity if you have 4 cell lithium ion in a 12 volt system. What if you had 3? It will have another problem. It will be like, yeah, you can fill it up, but you cannot drain it. So you get the idea, like you cannot utilize it, because our whole infrastructure, and I mean hundreds and millions of equipments, are specifically designed for that 12 volt range. However, because lithium iron phosphate is lower in voltage, it has that unique probability that, again, even in lithium iron phosphate best case scenario, still 80% utilization, but it is 80% plus utilization. You can utilize, like, oh, I bought a 100 liter tank, I can utilize most of it if I directly connect it to my normal inverter, and it is far more resilient. Like if over voltage happen, yeah, it will damage the battery, but it will not go boom. So that is why it's very useful for us. Now, it's very good for normal electric vehicle. If you are not doing, like, 0 to 60 under 2 seconds, if you don't want that kind of oomph, and you're like, city driving, something cheap, something practical, and or like e-rickshaws in India is very popular right now. If you want something like that, it's perfectly well suited for that. It's like you put and forget about it, because the range you're gonna get out of this is very little compared to, let's say, 300 kilometer. You're gonna get, let's say, 150. However, the lifespan would be much more. So you will go from yeah, I have to replace battery every 5 years to I have to replace battery every 10 to 12 years. That's a very big investment in terms of EV department. So that is why people love for this. On top of that, you may think like Tesla Powerwalls are like the big deal in power storage. Well, they are a big deal, but there are many other companies that make much more, sell much more, and most of them use lithium phosphate. Why? Yes, it does increase your transportation cost, but that's a very small part. And once you have that, once you have like hundreds of it in a field, and if it catches fire, let's say lightning happened, for crying out loud, something bad happened, it catches on fire, it's not going to set everything around it on fire. That is a very critical thing. So, or for off-grid storage, on top of that, the longer lifespan, the fact that you don't have to spend so much energy cooling it or maintaining its temperature, also make it much more cost effective. And it has one of the very interesting part, that it has calendar life of 10 years. What does that mean? Simply, cell was made, you charged it, you put it in a shelf. After 10 years, it still has some life left in it. If you did that with lithium ion, it will self-destroy itself if you have it, like, fully charged. That's why it's always recommended to 80% charge it, but don't charge it more than that. It will have lithium phosphate. That's the whole point. Like, you get more power, but you get instability, or you have safer, stable. Like, depending on your cases, many times people choose safer and stable options, simply because, again, you don't have to think too much about it. So what we can expect in the future? One simple reason: this technology has the highest probability of replacing lead acid inherently, and that's a very big deal, because even though we are talking about lithium ion, lithium ion, lithium ion, when was the last time you saw a car battery being lithium ion? Basically a normal combustion engine. When was the last time you saw a normal home UPS using lithium ion? When was the last time any places where we are using lead acid for 150 years you saw a lead acid system? It's very unlikely. But this technology has the probability, because it is quote unquote safe enough as lead acid. I have this system, basically 2 kilowatt 2 kilovolt sine wave UPS, and I have 220 amp hour batteries, 2 of them. Now this is also a fire hazard, simply because lead acid battery vents hydrogen, so you have to be like, you have to put it in a well ventilated place, otherwise it can set on fire. So it also has like even though we call it stable, it also has some inherent risk to it. Now, lithium system, lithium iron phosphate can almost match this. Like, yeah, I am as safe as this. So people are much more comfortable having, like, a room full of it in a building. You have to understand, if that room catches on fire, if it's lithium ion, that whole room would be nigh impossible to extinguish. So that is why it is a big deal that it can actually come very close to replacing that. And this sort of inverter, UPS, these circuits have been made for, like, 50 years. People know, like, oh, how I'm going to trickle charge it, how I'm going to set under voltage limit, everything. You don't want to change those things simply because it will cost a lot. So, and not to mention, lead acid batteries are kind of robust. They are like, I can take over voltage, I can take under voltage. Again, they will destroy themselves rather than destroying your building. But so it's a very well suited for that. Like, actually you can see, hey, lead acid is no longer sold because lithium iron phosphate replaced it. That's a very big deal. On top of that, many times you have low stress scenario, like a power bank for a building. It's gonna be rarely used once in a while, so you can have those scenarios, right? Like, okay, relax. And if you're like, hey, I want to run my whole building out of this, you're gonna build a bigger bank. You're not gonna be like, spiking a power bank for a few megawatts, like how you do in a car when you're trying to accelerate in 0 to 60. That spikes are really destructive. So in low stress scenario, this is like, I got this, I'm awesome. And it's put and forget. You don't have to, like, okay, like, I have this lead acid battery, it works, everything is nice and dandy, but it drinks water like there is no tomorrow. Like, I have to feed distilled water in this puppy every, like, 5 to 6 months, and it drinks liters of this. So it's not inherently, put and forget. You have to have some management. On lithium iron phosphate, it's put and forget. It's like, I got this. So there is a very bright future of lithium iron phosphate. You will not see it because it won't be, most likely won't be on a performance EV cars, but it will slowly make an impact, and it has the highest probability of actually replacing lithium iron from our world. So I will watch lithium iron phosphate's future very closely. So this was my presentation on lithium iron phosphate, why it's such a big deal for the whole battery world. Hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. And if you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I will try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.